is Unit 7, Day 7. If you're watching this, that means you are stuck at home for a while. And you're going to try to finish Unit 7 via video notes. So today is about simplifying radicals, which is a skill you're going to need for some of the ways that we solve quadratic equations, which is what you've been working on in the beginning of Unit 7. So a radical, which is this symbol, asks a question, and that question is, what number times itself is equal to the number under the radical? And that radical is also known as a square root symbol. So that's the question, what number times itself will equal the number that's underneath? Now sometimes they put a little number on that radical. It's called an index. So on this one there is an index of 3, which asks the question, what number times itself 3 times will equal the number under the radical? This is also known as a cube root. Prime factorization is writing a number in terms of all the prime numbers, the little tiny numbers that multiply to get it. So this is just one way to simplify a radical, but it's the way that we normally start off with in Algebra 1, and then we show you a faster, more efficient way in Algebra 2. So we're going to simplify these. Now the square root of 16 you might already know, because it asks the question, what number times itself makes a 16? And hopefully you know that to be 4. But to show you, and if you know that, all you got to do is you write down that it's equal to 4. Just like square root of 64, you should know is 8. 8 times 8 makes 64. Let me show you the process of prime factorization anyway, so that you can get used to it for the questions that you don't know, like square root of 24. So what we're going to do is we're going to try to break it down into the smallest number possible, and a bunch of them that will multiply to 16. Well, 1 doesn't work because you still end up with a 16, so I'm going to start with 2, since 16 is even, and I'm going to say 2 times 8 is 16. And if you always put the smallest number on the left, a neat little thing happens that I'll show you. So the 2 is as small as you can get. I can't break the 2 down into anything smaller, so now I'm going to take the 8 and break it into something smaller. Since 8's even, 2 will go into it, so that makes 2 times 4. And again, the 2 is the smallest. I put it on the left. I'm going to break the 4 down into 2 times 2, and the 2's are as small as you can go. Now what we are doing is called prime factorization, but around here a lot of people like to call this the hockey stick method, because if you go and you circle all the smallest numbers that you got, it kind of makes the shape of a hockey stick, and that's because you always put them on the left. Now, since the square root symbol asks you what number times itself, we are looking for pairs of numbers that are the same. So a group of 2. So I'm going to circle 2 2's here, and I'm going to circle 2 2's here. And for every group of 2, one of them is going to come on the outside of the radical. So I'm going to cross that group out and bring a 2 on the outside. I'm going to cross this group out and bring a 2 on the outside. And everybody who ends up on the outside ends up getting multiplied together. And 2 times 2 makes 4, which of course we already knew. So if we do it again with excuse me, 64, lowest number I'm going to try is 2. It's even, so I know it goes in. 2 times 32. Break the 32 down into 2 times 16, which is still an even number. So 2 times 8. 8's still even, so 2 times 4, 4's still even, 2 times 2, and here's your hockey stick. Again, square root means what number times itself. That means we need groups of 2. So here's a couple 2's, here's a couple 2's, here's a couple 2's, and for every group of 2, 1 comes out. So a 2 comes out of the first group, a 2 comes out of the second group, and a 2 comes out of the third group, and they all get multiplied together. 2 times 2 times 2 makes the 8 that we already knew. So like I said, if you already know what number times itself makes it, don't bother with this prime factorization. That slows you down. You can just answer it. But if you look at number 3, I have no idea what square root of 24 is, so we're going to do what's called simplifying the radical. We're going to take out any perfect squares we can, and the rest of it will stay inside. So, again, 24 is even, so I'm going to divide it by 2. 2 times 12. 12 is even. 2 times 6. 6 is even, so I know a 2 goes in. 2 times 3. And here's my hockey stick. Now notice I am only looking at, excuse me, the smallest numbers, the prime numbers right now. The 12 and the 6 got broken down. I ignore them right at this point. I need groups of 2. So I circle the 2 2's here. And that's it, because all I have left in my hockey stick is a 2 and a 3, and neither of them have a duplicate partner, so they can't make any groups with each other. So I only have one group of 2. For every group of 2, 1 comes out, so I have a 2 on the outside. But now I've got some stuff that is not going to make it outside the radical because they don't have doubles. So the 2 that I brought out stays outside. Square root, and any of the little guys that are stuck inside get multiplied back together, so 2 times 3 makes 6, which means our simplified radical is 2 square root of 6. Number 4, again, is an even number. 2 times 24, 2 times 12, 2 times 6, 2 times 3, and here's my hockey stick. Those are the only numbers I'm concerned about right now. And I want groups of 2. So here's a group of 2. Here's a couple 2's. That poor little 3's not going to go anywhere. So for every group of 2, take 1 out. So a 2 comes out of the first group. A 2 comes out of the second group. Both of those get multiplied together, so that leaves me with a 4 outside the square root sign. And that piddly little 3 gets to stay inside. So the simplification of square root of 48 is 4 square root of 3. Alright, throw some letters in with the mix. Don't worry about those, we'll do the numbers first. It's even, so 2 times 36. 2 times 18. 2 times 9. Now, first time we've seen a number that's not even. 2 doesn't go into 9 evenly, so I need to find another number. Well, the next number up from 2 is 3, and 9 can be divided by 3. It's 3 times 3. So here's my hockey stick. I want groups of 2. So I got a couple 2's here, I got a couple 3's here. For every group of 2, one of them comes out. So out of the first group, I get a 2. Out of the other group, I get a 3, and I have to multiply those together to give me a 6. But now what about the x's? Well, x squared means I have x times another x. Well, that makes a group of 2. For every group of 2, 1 comes out. So I cross those off, put an x out here with my 6, and then the only thing left that didn't get crossed off on this mess is this little 2 right here, so he stays in the radical. So that simplifies to 6x root 2. Alright, here we go again. Number first. That's even, so 2 times 49. Ooh, 2 doesn't go into 49. 3 doesn't go into 49. I shouldn't be looking at 4 because that breaks down. 5 doesn't go into 49. Shouldn't be looking at 6. 7 times 7. So that one took a little while to find it. And 7's can't break down any farther, so here's our little hockey stick. For every group of 2, 1 comes out. So a 7's going to come out. And now for the x's, I have 3 of them. X times x times x. But since I'm simplifying a square root, I only want groups of 2. So I'm going to circle 2 of the x's. For every group of 2, 1 comes out. So I cross them off, and I bring a single x out here with the 7. Now, we had a 5 out here to start with for the problem. Anything on the outside gets multiplied to whatever comes to the outside. So we actually have a 5 times 7x, and inside parentheses, we still have the 2 from our hockey stick and this extra x over here, so the 2x stays inside. So if we clean up the outside and actually multiply, that's going to give us 35x square root 2x for a final simplified answer. Okay, example 7. We already have that number on the outside, so don't forget about them. Simplifying the 12. 2 goes in, 2 times 6. 6 is 2 times 3. Make our little hockey stick. Groups of 2. For every group of 2, 1 comes out. So I'm going to put my 2 up here so I don't forget about that 3 that was already there. And I'm going to go do my x's. X to the 6th means I have 6 x's being multiplied together. I want groups of 2. So here's a group of 2, here's a group of 2, here's a group of 2. For every group of 2, 1 comes out. So cross off the first group, bring out an x. Cross off the second group, bring out an x. Cross off the third group, bring out an x. So if I multiply all this stuff on the outside, 2 times 3 is 6. X times x times x is x cubed. Square root of, now the only thing that didn't get crossed off is the 3 inside my hockey stick. Here's our simplified answer. Okay, example 8. Break down the 6 to 2 times 3, and that's as far as we're going to go. This says I have 7 x's being multiplied together, and I have 8 y's being multiplied together. And I want groups of 2. Now some of you might have seen or figured out a little bit of a shortcut when you're dealing with these letters and exponents. If you're getting the right answer using your shortcut, you go right ahead and use it. If you haven't discovered the shortcut, this is what we're going to do. So I need groups of 2. So there's a group of 2, 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 group of 2. All right, 2 and the 3 are going to stay in there. So I got 1, 2, 3 groups of x's. So 3 x's come out. 1, 2, 3, 4 groups of y's, so 4 y's come out, and that's it. So I have x to the 3rd when I multiply them, y to the 4th, and then inside my square root, the 2 and the 3 multiply back together to make 6, and then I got this little extra x over here, and here is our simplified answer. All right, just a few more. These involve cube roots. So cube root, which every once in a while they'll throw on the Regents exam, this is asking the question, what times itself 3 times makes the number underneath? We're still going to do the same prime factorization. Since 27's not even, 2 won't go into it, but 3 will, so we'll call it 3 times 9. 9 breaks down into 3 times 3. Make my hockey stick. Now, because it's a cube root, instead of groups of 2, I now want groups of 3. So I circle all 3 of these 3's, and for every group of 3, 1 comes out. So I get a 3 out here. And I'm looking for anything that I didn't cross off in my hockey stick, and everything disappeared, so 3 is my final answer. No radical. Okay, next one. I already have this 5 on the outside, so don't forget about them. 8 is even, so 2 times 4. 4 is 2 times 2. Make the hockey stick. Because it is a cube root, I want a group of 3. There it is. Everybody's in my group. For every group of 3, 1 comes out. I'm going to put them up here by the 5, so I don't forget to multiply those guys together. 2 times 5 makes 10, and since I crossed everybody off that's in my hockey stick, I have no radical. It's just 10. Number 11. Again, dealing with a cube root, but we still have to do the prime factorization. So 40 is even. 2 times 20. 2 times 10. 2 times 5. Make your hockey stick. And then I've got 5 x's being multiplied together over here. All right, we want groups of 3. So I'm going to circle the 3 2's, and I'm going to circle 3 x's. For every group of 3, 1 comes out, so I get a 2 on the outside, and cross off the group of x's and bring an x on the outside. So if I multiply all this outside stuff together, I will get negative 6x. And then the stuff that I didn't cross off, I've got the 5 in my hockey stick, and I got 2 x's here. So underneath my cube root, don't forget the little 3 that says it's a cube root, I still have the 5 in there, and I have the x squared still in there. And this is now simplified. Last one, number 12, cube root again. 2 doesn't go into 81, 3 will. So if you do 81 divided by 3 in your calculator, it'll tell you it's 27. So 3 times 27. 3 times 9. 3 times 3. Hockey stick it. And then I have 6 x's. Because it's a cube root, I want groups of 3. So I circle my 3 3's. Here's a group of 3 x's. Here's another group of 3 x's. Every group of 3, 1 comes out. So cross these guys out, and I get a 3. Cross those out, and I get an x. Cross those out, I get another x. So that makes a 3x squared when I multiply them together. And then I still got this little guy in my hockey stick, so I write cube root, don't forget the little index of 3, of 3. Final simplification. All right, day 7 is the homework that accompanies this lesson.